folks. Welcome to
Vector Calculus.
Folks, welcome back to the next lecture in Vector Calculus. Today we're taking a look at yet another application of the cross product. Namely, we have to find the area of the triangle given by the following three vertices. So find the area of the triangle with vertices -3, -3, 1, -2, and 3, 3. So, what do we have here? Here we have 3 points. How do I know these are points? Because they have an x coordinate and a y coordinate. Okay? So when you have 3 points, what do you really have? Well, connect those points up, and what you get is a triangle. Now, our goal is to find the area of this triangle, and of course we can do this a couple of ways. You might say, why don't you just do half BH? Well, I'll tell you why. Because this is not necessarily a right triangle. Half BH only works for right triangles. This is not a right triangle. So we have to find a different way. Since this is not a right triangle, we have to find a better way to find the area of this triangle. So how are we going to do that? Well, the answer, surprisingly enough, is going to be the cross product. And why can we use the cross product to find the area of a triangle? Isn't the cross product for parallelograms? Well, good question. If you have a triangle like this, which is basically composed of 3 vectors, take one of the vectors, shift it to the right, and what you end up with is a parallelogram. So if I have 2 vectors A and B, and I take the magnitude of their cross product, I know that's going to give me the area of this parallelogram. But I only want the area of this triangle. Right? I don't want the full parallelogram. I just want this triangle's area. So I'm going to take half of the magnitude of the cross product. And that's all there is to it. That's all there is to finding the area of a triangle. So let's go ahead and do that. We're going to need half A cross B, and of course A cross B, another way we can write that is magnitude of A, magnitude of B, sine of theta. Much like the dot product, except instead of cosine of theta, we have sine of theta. That's the big difference. Okay, so what are our vectors A and B going to be? Well, we can use these points, right? Let's call this point P, point Q, point R. Okay, so we've got our 3 points. So let's find our first vector PQ. So our first vector PQ is going to be what? Our first vector PQ is going to be 1 minus -3, which is 4, and 2 or -2 minus -3, which is +1. Okay, good. And what about our second vector B? What is our second vector going to be? Well, take PR, right? So 3 minus -3, again 3 minus -3, you get 6, 6, you get 4, 1. We're going to take the magnitude of these 2 vectors, because look what you've got here. You've got the magnitude of the vectors. Remember, at the end of the day, you want the area. You want a scalar quantity. So let's take the magnitude of these guys. What's going to be the magnitude of my vector PQ? Well, that's simply going to be the square root of the square and the sum of the components. So I'm going to have 4 squared plus 1 squared. And what's that going to give me? That's going to give me square root of 17. Likewise, to find the magnitude of my second vector PR, I'm going to take the square root of the sum of the square of the components. So I'm going to have 6 squared plus 6 squared, which is going to give me what? 72, which is just 6 root 2. 6 root 2. Okay, so I've got the magnitude of A, magnitude of B. Final thing I need is sine of theta, or just theta, right? How do I find theta? Well, this one's a bit tricky. You can bring your protractor. That's not going to help you much because this is not drawn to scale. What you could also do is use the dot product, right? Remember, the dot product can be used to find the angle. So let's go ahead and do that. Remember, the dot product tells us the angle between 2 vectors is going to be the arc cosine of the dot product of the 2 vectors, A and B, divided by the magnitude of the product of the 2 vectors, okay? And if you don't know where this formula comes from, go ahead, rewatch our lecture on dot products. It's going to be plain and simple. This is just a projection formula. That's all there is to it. No memorization required. And as you know, memorization is a crime. here. So let's go ahead and plug in the numbers. Okay, so we're going to have arc cosine of the dot product of A and B. What's that dot product going to be? Well, it's going to be 4 times 6. 4 times 6 plus, let's write our plus nicely. 4 times 6 plus 1 times 6. All divided by the magnitude of A. And what's the magnitude of A? Well, it's going to be square root of 17. What's the magnitude of vector B? It's going to be 6 root 2. Okay, so I'm going to end up with my angle theta being arc cosine of what? 24 plus 6, which is 30. Divide that by 6. So I'm left with 5 over root 34. Okay, so that's going to be my angle theta. And now all we need to do is just plug in the numbers, right? So just the area of my triangle is going to be 1/2 of the magnitude of vector A, which is what? Square root of 17. Magnitude of vector B, which is 6 root 2. And sine of my angle theta. Sine of arc cosine of 5 over square root of 34. And that right there, ladies and gentlemen, go ahead, put this in your calculator, and you're going to get the area of this triangle. And that's all there is to it. That's it for this lecture of vector calculus, and we'll check you out next time.